Okay, this is tutorial number 11. The different equation for irrotational plane compressible gas flow is given like this one. So you just imagine that you are using Navier-Stokes equation, and there are two types of axes. One is polar coordinate and one is Cartesian coordinate. So for Cartesian coordinates, I show you the example in last video, but for polar coordinates, I would like to show you, I would like to share you here. So this is the Navier-Stokes equation, and then you substitute with all the parameters, and then you will get this equation. Let's say that is the situation. So where phi is the velocity potential and A is the variable speed of sound in the gas, in the spirit of section 292, non-dimensionalize this equation and define any parameter which appear. So the idea is, for example, from your study, you substitute all the parameter you want and so on and so forth, and finally you will get this one. And then you try to analyze, so what parameter that you could use in your analysis. Okay, we could do the dimensionless analysis. So for example, we look all the parameter here. We have phi, we have t, we have u, v, and a, and so on. Okay, so we have the non-dimensionless variable is listing like this. So and then we substitute all the parameter. So and then we found that if we factorize that, so we found that there is no dimensionless parameter appear. So and then here actually the correlating A star with temperature and velocity would in fact lead to Mach number and specific ratio. Okay, it is because we neglect the value of A here, because A is given as speed of sound in the gas. Okay, so this is the simple calculation. You will get there is no dimensionless parameter, but if you substitute your dimensionless parameter into the A here, so you will get the speed of sound. So I think the speed of sound means the Mach number. So the Mach number is actually the velocity of certain object divided by the speed of sound. And then the speed of sound is actually need to be calculated by using the idea of v square root kRT, which is the k here is the gas constant for certain gas. So and then R is the gas constant again, with normally we divide 8313 or 8314 divided by the molar mass. Okay, and then the temperature is in Kelvin. Okay, so bear in mind, if you do research about the gas here, so the value of K and R is depend on that type of gas. So normally for air is 1.4. Okay, and then the value of R here for air is 287. Okay, but if you are doing another type of gas, so hydrogen, nitrogen, and so on, so means that you need to make sure that you use the correct value.